Our construction task for this video is constructing a line perpendicular to a given line that passes through a given point. Now, we just got through finding the perpendicular bisector of a line segment. So the fact that both of these tasks involve perpendicular lines is going to let us use what we already know in order to solve this new problem. Let's take a look at our paper. All right, so right here, I've got a little copy of what the perpendicular bisector construction looked like. And over here, I've got a line and I've got a point. So I want to construct a line that's perpendicular to this line that passes through A. All right, and the two tools that we have, as always, are a compass and a straight edge. A straight edge can only connect 2 points, and a compass, there's only so many things we can do with a compass. So we're going to start off doing the one thing we know how to do. So I'm going to open up my compass to some distance that's going to get me to this line, and I'm going to find 2 points on this line that are the same distance away from A. Oof, this is hard work. I'm not usually doing constructions from this vantage point, so I am moving around here. All right, so there is my points. They're both the same distance from A. I'm going to call one of them B and another one C. All right, and I want you to look at this perpendicular bisector construction, and I want you to see if you can spot any similarities or differences between them. Well, these 3 points look a lot like the 3 points in the perpendicular bisector construction, in that the point that's not on the line is the same distance from B to C. C is the same distance from A to B. It's just that we constructed them in a different order. This one we started with A and made B and C. This time we started with A and B and constructed C. So if we want to construct a perpendicular that goes through this point, just like we constructed a perpendicular that goes through this point, all we need to do is construct the perpendicular bisector of B and C. So we don't need to construct the first point because it's already there. We already know that A is the same distance from B and C. So all we need to do now is just to find the second point. All right, so there is a point from B and a point from C. And right where those two arcs connect, that is the same distance. So once again, now we have 2 points that are the same distance from B and C. So therefore, the perpendicular bisector between B and C must be the line that connects those 2 points. And so since that's a perpendicular bisector, we just completed our task of finding a line that is perpendicular to this line that passed through A. All right? Now, sometimes people consider it to be 2 different tasks in this case, and in this case down here, where A is actually on the line that we're constructing. But it's really exactly the same task. So the first thing we're going to do is we are going to find 2 points on the line that are the same distance from A, and that's going to be our B and C. And then we just need to create the perpendicular bisector of BC. Except that we don't even need to go through all the steps. We only need to find 2 points that are the same distance from B and C. And we already have this one. A is already the same distance from B and C. So I'm going to open up my compass just a little bit wider. And there's a point, and there's a point, and X marks the spot. So here is a second point. So you notice I didn't even need to make an extra point down here because I already have 2 points that are the same distance from B and C. So I connect them, And shazam, there is a line that's perpendicular to our original line that passes through A. All right, so that's how you can use the notion of a perpendicular bisector to solve this extra task, which is constructing a perpendicular to a given line that passes through a given point.